Okay, we are going to do a vertical motion problem where we are going to drop something from a canyon that's 1,800 meters deep, and we want to figure out how long it's going to take for an object to reach the bottom. So we're dropping this thing, and we're starting at 1,800 feet, and all we know is we're going to use acceleration as negative 9.8 meters per second squared, which is gravity on the Earth. You'll recognize this if you've taken physics. Only in physics they gave you the equation. We're going to find it. Okay, so we start out with we have acceleration, and we're going to take the integral of acceleration, and the integral of acceleration is velocity. So when you integrate, you look at what you would have had before you took the derivative. We're going backwards from derivatives. So that was t to the 0, now it's t to the first plus some constant. And because the derivative of a constant is 0, so we always have to account for that. And then we're going to take the integral again, because we want to get to displacement. We want to be able to use our distance. So displacement is the integral of velocity. Now, we're raising this to the second power. When you raise it, you always divide by the power you raised it to. Sorry, this was a negative, because it always falls to the ground. The constant, we don't know what it is yet, but it was to the 0 power, now it's to the first power. You can divide by 1 if you want. Plus we have a new constant. So this is the formula for displacement. So now we need to plug in our information that we know. We know that the initial height is our displacement at time, or our initial height is our d0, or call it our constant when time is 0. So as you can see here, we have two variables, and we're trying to figure out when the displacement is 0. And so it's hard to solve a two-variable equation unless you have one of those variables. Well, we do. We know that the initial velocity, or the velocity when time was 0, is 0. So you can take this term and it becomes 0, because we're dropping it in a free fall. We're not throwing it or pushing it. If we were doing that, we'd have to change the values in our equation. So now it's a simple radical equation. And so we can take this and divide 1,800 by 4.9 and take the square root of that, and we should get a value that works. And so our time, we'll pause it here while I do my calculation. So after you take the square root, you realize you have your time is 19.1663. Go 4 decimal places when you're doing AP Calc problems. So it takes that long to get to the bottom of the canyon. So to go further with this problem, the question might say, what is the velocity when it hits the ground? So if you go back to the equation that we started with A equals negative 9.8. If you integrate that with respect to time, you get the velocity equation. And again, our initial velocity is always the constant. And so our velocity can be calculated by taking negative 9.8 times the 19.1663, and we can calculate that and multiply by negative 9.8, and we get your velocity as negative 187.8297. And that does not account for terminal velocity and wind resistance. This is just pure velocity by our equation in meters per second.